Okay, 1.2 acceleration in 1 and 2 dimension. So knowing the acceleration is change in velocity over time. Change in velocity is final velocity minus initial velocity. Make sure the velocity is in a vector form. So this is average acceleration. What is instantaneous acceleration? If you have a velocity time graph, so this is the velocity time graph and it is curved line, let's say, it means the velocity gonna change. At different point, you have different velocities, right? For average velocity, you just take initially and final point and you find the slope of that. This slope of this line will give you the average acceleration. The slope of velocity time graph will give you what? Acceleration. But if you have the same graph, you find the slope of tangent line there, right? The slope of tangent line will give you the instantaneous acceleration, means acceleration just at one point. Instead at average acceleration means from 2 points, final initial. Instead instantaneous means just instantly at 1 point. Okay, so now this question, a racing car accelerates from rest. So means initially the velocity is 0. Accelerate from rest to 96 km/h west. So the direction is west. 96 km/h is going to be your final velocity. 4.1 seconds will be your time. So we know that final velocity minus initial velocity divided by time. Final velocity minus initial velocity, 96 minus 0 divided by 4.1. Make sure this is km/h divided by second. You can change this 1 km/h into meter per second. Like before we have shown it, but here they just good with this answer. A motorcycle is traveling 23 meter per second north and apply the brake, producing an average acceleration of 7.2 meter per second power to south. So here is north, this is south. If I need to first turn the south to the north, why, how? 7.2 meters per second square south, south is negative north. Okay, now they have the same direction, so I can say that average acceleration is equal to final velocity minus initial divided by delta t. I can rearrange it for final velocity, multiply average velocity by delta t, and then bring the initial velocity to the other side. This is the equation that you have. Initial velocity is 23. Average acceleration is going to be negative 7.2 multiplied by time, 2.5. And you do it, the final velocity is going to be 5 meters per second north. Any question?
Zara. I saw MDM.
Okay, so here is the question I want you to do. Question number 4, 5, 6, and 7. The one that has an answer here, okay?
Yes.
This is page 20. Yes. Let me just show you this graphing motion with constant acceleration. So you have a displacement time graph. You want to do the velocity time graph from that and acceleration time graph. There are 4 different situations for it. I would like to explain it to you. Then I'm going to come back here to go over this example with you. Let me just share a new page. Okay, here we have displacement time graph. Let's say here is like that. Displacement time graph. We have 4 situations. Okay, for this one, I want to do velocity time graph, right? As you see, the instantaneous rate of change is the slope of the line here. See the slope of the line, a displacement time graph represent the velocity. What happening to the velocity? The velocity is getting sharper and sharper, right? The slope is getting bigger and bigger. So means initially the slope here is 0, it started at 0, and then the slope becomes sharper, sharper, bigger, bigger, and positive. So that's it. Now let's just do velocity time graph here. The slope here is very sharp, and as we go, the slope going to 0, right? So I have to start very big velocity, and then I need to, my velocity need to go 0. See, at this, the velocity goes to 0. Here all the way positive. See, the slope all the way here is positive. Here for velocity time graph, the slope at the beginning is horizontal line. The slope is 0. It's getting sharper and sharper, but in negative direction, right? Getting very sharp here. So I have to start with 0, but I do not go up because the velocity here is negative. I go down. Velocity is increasing in negative direction. Again, here, the velocity is very sharp negative, starting very sharp negative, and at the end here is getting close to 0. I want to draw that velocity time graph. Let me just move this one around. I have to start with a very big negative velocity, then I need to go to 0, right?
Yes.
So this is velocity time graph. Let's just do acceleration time graph. This is acceleration time graph. The slope of velocity time graph will be acceleration. Here the slope is positive, so it's just here. Acceleration time graph. The slope here is what? Negative. We just put a line like that. Here a slope is negative. Like that. So this is acceleration time graph. And the slope here is going to be positive. Okay, see, the slope here is increasing, the velocity is increasing, means you are accelerating, right? Acceleration motion. Here is the velocity getting slower and slower, true? So it's deceleration. The velocity getting bigger, bigger in negative direction, but it is accelerating in negative direction. Here, the slope getting smaller and smaller means this is deceleration. Pay attention, here velocity is positive, right? Velocity here is positive. Acceleration here is positive too. Here is the velocity positive, acceleration negative. Velocity positive, acceleration negative. Here is the velocity negative. See, is under x values. The velocity is negative.
Yes.
Negative as well, right? Here is velocity is negative, acceleration positive. As you see, when both of them is positive and both of them is negative, you have acceleration. When the velocity and acceleration has the same sign, it's going under acceleration. But if they have a different sign, one positive, one negative, see here, one negative, one positive, it is a deceleration motion. You got it?
Yeah.
Let
me take a picture. Yeah.
Yeah, please. So here I'm gonna go to the textbook again. So there you go, we did talk about that. You know, the area under acceleration time graph is velocity. The area under the velocity time graph will give you the displacement. Okay, for the question, I want you to do this. This is just question number 12. This is page,
Oh.
page is that? 24. Page 24, number 12. Okay.